Well, thank you so much for that introduction, and thanks so much for this invitation. I'm absolutely honored to give a talk to the Amsterdam crowd. It's certainly a great place full of awesome mathematical psychologists. So it's really great to be invited, and I'm happy to give a talk, and just great to be here. So, I'm going to give, while I'm giving my talk, I don't mind if you interrupt me. We can have this be a conversation as well. It doesn't bother me in the least. But I won't have the video portion on. So if you have a question, you'll have to speak up. I'm sorry about that. All right, cool. So what I'm going to talk about today, I do, different things, but kind of a unifying thread, as Angelica mentioned, is trying to better understand how people make decisions and how we can model that. And today I'm going to summarize 3 papers that I think kind of neatly encapsulate kind of a nice mixture of theory, empirical work, and some fun Bayesian statistical modeling to kind of tie everything together. And I hope you find it interesting. So where I would kind of like to start is with kind of an axiomatic perspective. And this is a question I find really interesting. So we can say, are there fundamental properties of choice that hold for many individuals? And the thinking is that we all make decisions differently. People make different choices than other people would make in different contexts. And, that's pretty easy to establish, honestly. But the question I really am interested in, are there certain properties of those choices that while we may make different choices, are there certain invariants or aspects of those choices which tend to hold within individuals, across different contexts, and so on. And from that, if we can understand that, what does that mean for developing further theory? And that's kind of a unifying question. And so today we'll talk about transitivity, and there are many other types of properties that I'm interested in, or we can look at more esoteric things like double cancellation, stuff like that. But for now, let's just think about something relatively simple. So we think about transitivity of preference. So this is very, very simple property of 3 choice options, let's say, or for any 3 choice options. If choice option A is preferred to B and B is preferred to C, then A must be preferred to C. Basically, this is a necessary condition for developing most any type of ordinal utility function, because the idea is it's from a measurement perspective, you're trying to assign numbers to choices or choice alternatives. And so if you didn't satisfy transitivity, you would end up with a cycle. And, there's all kinds of arguments, some more plausible than others, that, if you truly had intransitive preferences, then you could be turned into like a money pump, where you could be, you could be sold different goods and then be sold back the original good you wanted in the first place at a loss. Stuff like this. And sometimes this stuff may happen. But that's sort of the basic property we'll start with as we move along. And let's see here. So we can start with monetary choice. So this is kind of where, starting with Tversky's famous paper in 1969, he tested transitivity of preference, I think in a very careful way, using monetary choice gambles. And what kind of would make it interesting is that he was trying to come up with choice stimuli that implied certain trade-offs. And so here we have trade-offs between reward magnitude and the probability of a reward receiving a reward. So all the choice options were sort of framed as these gambles. And, this is kind of a classic gamble setup. And it's familiar if you're used to playing board games or things like this, where you can imagine this being a spinner, and the shaded area represents the probability of winning, in this case, $19 US. And if you spin the spinner and it falls into the red, this represents the probability, or this area represents the probability of winning nothing. And on the right side here, we have another gamble. So the probability of winning is smaller, but the amount you could win is greater. And so you have this trade-off between the probability of winning and the dollar amount. And so by using these trade-offs, you can try to induce violations of transitivity. So anyway, that's just kind of, we'll talk more about that here in just a moment. With the basic idea being, the basic idea is that, if you are choosing according to some sort of heuristic, what can happen is that you can violate transitivity by not paying enough attention to reward magnitude in a sense. So long story short, this particular monetary choice transitivity experiment has been run many, many times by many different people over the years. And, there's some disagreements about, of course, we could get in the weeds on that, but a majority of individuals, for most studies, show that decision makers tend to satisfy transitivity even when the experiment is designed to induce violations. Now, this is fairly stable under intertemporal choice stimuli, time pressure, and display manipulation. So it's a fairly stable property. And this is good news for all those people that use expected utility theory or cumulative prospect theory, because that is indeed, those are transitivity requiring choice theories. But what I would like to do is we can start to maybe branch out beyond simple monetary gambles. So I'm willing to entertain that maybe not every choice we make in this world can be reduced to a monetary gamble, which leads to the next question. So this is we're going to ask the question: do young adults make rational sexual decisions? And I'm going to qualify that and be very precise about what I mean by that. So what I'm going to summarize here is a paper that my colleagues and I published in Psych Science last year. And I'm happy to send all these papers around we'll talk about today, where we were interested in understanding transitivity within the context of risky sexual decision-making. And what we did is that we developed a new task. And so I mentioned the previous task to you a little bit. You have some gambles, some probability of winning, some probability of losing. And so with my colleagues and I, we developed this thing called the novel sexual gambles task. And let me explain how this works. So in this task, you're shown a picture of a face, and you're then given these various probabilities. The context is you need to choose between two people. You're going to be shown a series of individuals and associated risks, and you're going to choose which one you'd like to have a one-time sexual encounter with. There's all kinds of stipulations according, relevant to the experiment, like, not going to talk about the risk of pregnancy and all these other things. But you have to choose who you'd rather have a one-time sexual encounter with. And this is what makes it interesting. This is where the gamble part comes in. So each face is going to be associated with a probability of contracting a sexually transmitted infection. So that's abbreviated STI. And on this one-time sexual encounter. Now, that's clearly a bad thing. That's clearly a negative. And that was then, that variable, when we were designing the stimuli, was traded off with the attractiveness of the face. So these individuals are stimuli that we took from the Chicago Face database. So I wasn't familiar with this beforehand, but what it is a bunch of, it's a norm stimuli set based on attractiveness. So you have a whole bunch of pictures of men and women who have been rated by many, many, many individuals on their level of attractiveness, just making a very simple, as you see, this make kind of a non-sexualized pose and look into a camera. And I mean, I find this database kind of interesting in a lot of ways. I mean, it's publicly available, so presumably you could look yourself up if you participated in it, which is a little funny. But the basic idea is that since we could then have some measure of attractiveness for these individuals, we could then design the gambles in such a way that we could then modify their hypothetical level of STI transmission. So that's the basic idea. And we can design the stimuli in such a way to try to induce violations of transitivity. So if you're making choices according to, let's say, a lexicographic semi-order, which is described as choosing attribute-wise, you might look at these two levels of sexual risk, of STI risk, and say, well, they're relatively close. I'm going to choose by attractiveness. And if you do that for enough gambles, eventually the risk may become large enough where you would revert back to the original choice. And that would induce a cycle, induce a violation. Now, we had multiple stimulus sets. So high versus low probability of STI contraction. These are really, really high probabilities of STIs. So these were actually modeled after the Tversky probabilities of the gambles we saw. The other stimuli set is actually based on the literature and what people's subjective beliefs are about the risk of unprotected sex and transmission of STIs. And we also had then two task conditions, common versus incurable STIs, where we would describe, in one condition, the STI is something very simple, treatable, that you would, quickly be out of your system, whereas the other one was more persistent. And so this way we can also vary sort of the magnitude of that loss. Does this make sense so far? Okay, so it's kind of fun. So what we did, and of course all of this is totally hypothetical, but we thought this would be an interesting way to try to get at how people may be evaluating these different risks. Now, how we designed the study, so again, people would see multiple presentations of each of the gamble pairs, and there were multiple sets, and people could choose what set they wanted to see. There were men, women, all kinds of things. So in our study design, we ran this twice. The first time we ran it on an undergraduate student sample, and then we replicated our results on a community sample about 8 months later. So for the community sample, it's community young adults. These are not undergraduates. These are individuals just in the community of Columbia, Missouri. Now, everyone completed, at least in the community, people completed a monetary version of the gambles task, so very similar to the Tversky task, our sexual gambles task, and they also completed a cognitive appraisal risky event scale. This is the CARE, and we'll talk more about that here in just a little bit. This is a measure intended to measure individuals' beliefs about sexual encounters, their prior sexual history. Basically, it evaluates how risky people think about sex and sexual related things. And we're going to model these decision strategies using two different classes of models. The first we're going to call the weak order mixture model. This is going to be our transitive choice model. So preferences are going to be weakly ordered, allowing ties, and this is going to be representative rational transitive choice. I could spend hours talking about the details on these things. The basic idea is that different individuals can certainly have different preferences, but at all times, an individual satisfying this model must be choosing according to some sort of weak ordering on the transitive weak ordering on the choice alternatives. The second model that we'll consider is the lexicographic semi-order mixture model. This model allows for intransitive preferences, and it's representative of heuristic choice. So this is the model that encapsulates this idea that, oh, well, I'm going to compare the attractiveness, and if two people are attractive enough, I'll then move to the next attribute. So this is the idea that in a very heuristic fashion, you examine choice alternatives attribute-wise, making a choice only if the attributes are sufficiently different, if they aren't too close together. What's kind of neat about this in a Bayesian sense, and I'll talk about the modeling here in just a moment, is that if we think about a person making choices as being well described by a set of choice probabilities, then these two models define a series of linear constraints, a series of linear inequality constraints on those choice probabilities. And we'll talk about using basically order constrained statistical inference. And there's certainly lots of individuals at Amsterdam working on some of these very types of problems, which I avidly read. And the idea is we're going to use a simple statistical model with a Dirichlet prior over this space of inequality constraints. So long story short, just to briefly summarize, we have two types of models, and we're going to, that are defined by inequality constraints on choice probabilities. What we're going to do is instantiate a Bayesian model where the prior encapsulates these two different spaces. And then once we connect that with the data, we can calculate Bayes factors in favor or against these various models. Now, so we have our rational choice, which is our weak order mixture model, and our heuristic model, which is allowed to be intransitive. The substantive models were then also tested against an unrestricted model using Bayesian model comparison, just as I described. So we're going to use kind of the rule of thumb, say a base factor greater than 100 is decisive, 3 to 10 is strong, 1 to 2 isn't so good. But this is the basic setup. Now, so what we're going to do is that on the student sample, we're going to carry out these base factor classifications. And by classifications, you have to have a large enough base factor. You have to have a winning model, and it has to win by, let's say, 3 at least, according to the next best model. For the monetary gambles, it was, we pretty much perfectly replicated what we had seen before in the literature. Most people, about 80% of people, were well described by the weak order transitive model. They made mostly transitive choices when choosing among the monetary gambles. But there was still about 16%, 15% that seemed to choose according to our heuristic model. Now, interestingly, when we moved to the sexual gambles, nearly everyone was rational by the transitive weak order mixture model. And this was actually very interesting. It's sort of, even the people who could be, induced to violate transitivity on the monetary gambles, all of a sudden made very transitive choices when presented with sexual gambles. And we replicated this in the community sample as well. So again, we had this case where, even people who were mostly satisfied or would choose according to some heuristic, it's a completely different ballgame when those same individuals made the sexual gambles choices. So that's very interesting. So clearly, or at least for this type of stimuli or this task, the sexual gambles, even though they were designed to try to, induce violations of transitivity, individuals almost universally, with just a couple exceptions, chose in a fully rational manner consistent with transitivity. And with the weak order mixture model, they're actually choosing like consistent with random utility. There's these additional constraints you can think of. I found this very interesting, that somehow, even though it's less structured, people weren't given numbers of the rated attractiveness level, they were just shown faces. But yet people were choosing in this highly rational way, which was very interesting to me. And so then what we did is that we decided to do a little bit of exploration and try to understand this variability within the models. So almost everyone for the sexual gambles was choosing according to the weak order mixture model, the transitive rational model. But as I said before, there are many different ways that you can satisfy that model. And so we wanted to try to understand how much heterogeneity we had within the group, and whether people were choosing in a very similar way, or whether people were choosing, everyone's choosing rationally, but are there differences? And so we carried out a p-median clustering algorithm to group participants by similarities in their choice patterns within the transitive model. No assumptions about the number of clusters or behaviors, and the algorithm provides an exemplar for each cluster whose behavior can be used to infer the behavior of other members of the cluster. So it's just like p-median, p-medoid, call it whatever you want. So we applied the clustering algorithm to the high and low risk sets of each study. We found 2 cluster solutions for both sets in the undergraduate sample and for the low risk set in the community sample. And these were pretty easy to kind of understand. There were people who more often chose more attractive people, and those who made and those who more often chose the less risky option, risky in terms of minimizing the STI risk. And then we found some solutions, like for instance, in the high risk community sample, where there were many such clusters, where people were doing various combinations of the 2 factors, which is pretty interesting. But the nice thing too is that we did find some sense of the ecological validity, where we had the stimulus sets were also broken down by common versus serious STIs. So on the left side, we think of this as like treatable STIs, and on the right side, we think about serious STIs. So if we look at the size of the clusters, we can see that individuals in the serious, when you frame the question as serious STIs that are very difficult to treat, many more people were clustered according to the choose by minimizing STI risk, which you would hope that to be true. And indeed, that's what we found. There were still some people that were really, that didn't bother them at all. And they were still, clustered into the high risk sort of choices, but there you go. Now, here's an interesting thing, and this is fun. So what we decided we wanted to now try to understand whether these choice patterns and classifications were at all related to people's beliefs, prior sexual history, and that's where the care comes in, that measure we talked about earlier. So we can ask, is cluster membership associated with self-reported behaviors and attitudes about sexual risk-taking? So we carried out order-constrained Bayesian inference using the Bayes factor package, and we generated a series of hypotheses for each data set with an interpretable two-cluster solution. Now, I'll explain again a little bit more clearly what I mean by that. So the care has various subscales from various items about degree, and it's measured on Likert scales of like degrees of endorsement. So like past involvement, like how positive do you feel about sex with a regular partner, sex with a new partner, things like this. So, we talk about expected positive consequences. It's, various items relating to that, expected negative consequences. And behaviors include sex without a condom, sex with a new partner, and so on. And this leads to some very clear hypotheses. And so what we can say is that, well, for past involvement, depending on your expectancies about sex with a new partner, people that chose and that prioritize physical attractiveness more so than minimizing sexual risk or contracting STI risk, we hypothesize that they would be scoring higher on those measures, and so on. This is pretty clear. I mean, one way to think about the two cluster solutions is that we had some people that were very risk-seeking, trying to maximize physical attractiveness in their partners, whereas other people were very risk-minimizing, caring much less about physical attractiveness and caring much more about minimizing that risk of STI. And so what we did is that we could then carry out Bayes factors at the item level using the Bayes factor package, just a Bayesian t-test. And what we did is that through an order constraint, because we made this joint ordered prediction, so we can think about this, we can test the conjunction of all of these predictions. And in doing so, we can then carry out this order constraint inference test, and we find a Bayes factor of about 12 in favor of the predictions that we made. So this isn't, super overwhelming evidence, but I think what it does point to is it does point to some signal that individuals who chose in a very risky manner on our sexual decision-making task, this does to some degree correspond to their attitudes and beliefs, which are also correspondingly risky regarding their prior sexual behavior and their expectancies about the sexual behavior. So it looks like there could be some signal there in an interesting way. So our preliminary conclusion is that nearly all decision makers use choice strategy based on optimization or transitive weak ordered mixture model when evaluating sexual partners. What's interesting about this especially is that the weak ordered mixture model and the lexicographic semi-order mixture model are very parsimonious models. For instance, the weak order model takes up less than 0.5% of the space of all choice probabilities. Some of that space is certainly a likely space for people to make choices, but the models are certainly not vacuous. They have quite a bit of a bite. And we also found support for ecological validity of the novel sexual gambles task as a predictor of real world attitudes. And we've run a replication of this where we actually got people intoxicated when they made choices, and we're finding very similar things so far, but I guess more on that in a future talk. Now, so the first part of the talk was this idea that, let's see if we can move decision-making in testing transitivity, testing these properties into a different domain. Different types of choices that maybe don't map so well onto monetary gambles, or one could make that argument. Now we're going to go back to monetary gambles, but we're going to ask, can we cognitively impair individuals? And what would that look like? How will that affect the properties of transitivity, weak orders, things like this? So we're going to ask, is alcohol intoxication associated with violations of rationality? Now, it turns out alcohol is a good choice for directly impairing cognitive function. If you've ever drank, then you would probably agree with this assertion. Alcohol intoxication has been shown to reduce a number of cognitive abilities required for sound decision-making, attentional capacity, memory retrieval, inhibitory control. What's interesting about alcohol is that, it definitely impairs the decision-making process, and it impairs cognitive functioning, and it's not nearly as localized as some other drugs. It hits a lot of different areas of the brain. And, maybe it wouldn't be such a big deal, but the problem is that people often make very serious, risky decisions while they're drunk. For instance, the decision whether or not to drive a car home after a night of drinking at the bar, risky sexual decisions. People make serious decisions and they do so while they're impaired in this way. And that's why I think it's kind of worthwhile thinking about what exactly changes when we get drunk and we make these decisions. So for this study, we recruited 34 participants, all of legal drinking age in the US, from the surrounding community. And we're going to test transitivity of preference on these individuals. And we're going to do so by getting them drunk in a lab. So this is, of course, in collaboration with several of my colleagues here at the University of Missouri who do alcohol intoxication research. And this experiment consisted of 2 sessions, an alcohol session and a comparison no beverage sober session, the order of which was counterbalanced. So you actually bring people in the lab, and there's all, as you can imagine, there's all kinds of protocols you have to do to make sure it's safe. But you do get a person, by measuring their blood alcohol, their breath alcohol content. We got them up to a peak of about 0.1, about 0.12, which is pretty impaired. But not, it's reasonably impaired. And they were able to safely monitor them, and they did this experiment at peak intoxication. So at the peak of the ascending limb. So, and our choice stimuli for this experiment were just the monetary gambles, very similar to Tversky, just kind of updated to reflect dollar values. So this is a very simple test of transitivity. Part of the limitation is that we wanted the individuals to do this task and this experiment at peak alcohol intoxication. And if it takes too long, people obviously sober up. So it has to be relatively quick. And what we found, and kind of interesting, people really didn't we used the same types of models. I guess random utility, this is actually the weak order mixture model. And what's interesting is that whether you're sober or drunk, we found people were satisfying transitivity, satisfying the weak order model at about the same rate as when they were sober. And this was kind of interesting. So even impaired, people were still satisfying transitivity or violating transitivity at the same rate. So we still have some violations. We have people that are described by the lexicographic. So this is not, this doesn't map on perfectly to the sexual gambles where everybody was rational, everybody was weak order. Here, there's the same mixture we sort of see before and have replicated many times, but alcohol doesn't really seem to change that, or at least the pharmacokinetic effects of alcohol, like just the act of being drunk, the act of that kind of impairment, which is interesting. Now, of course, there may be other contexts, like people don't usually get drunk in a lab for fun. So there's that, right? So people are often in other contexts, they're at a bar, they're with friends. So, I mean, this isn't by any means definitive, but it was interesting. So of the 36 participants, 12 were classified as having choices best described by a lexicographic semi-order model for at least one condition. Of these 12 subjects, half switched in the predicted direction, where upon impairing them, they would switch to something more heuristic and transitivity violating. And we really didn't see that. Now, while preferences were generally stable, there was an effect of alcohol in the perception evaluation of similar gambles. And what this meant were when people were making choices among what we would call adjacent gambles, gambles with very similar expected utility value, expected value, people were more likely to just guess or say they're indifferent when evaluating those. And that's consistent with some of the alcohol cognition literature. It's like their ability to distinguish between similar things is impaired when you're drunk. So that was kind of an interesting process. And so what we found from that paper is, just to summarize, that whether people satisfied transitivity or not, at least on the stimuli, was relatively unaffected by alcohol intoxication per se. And that isn't to say that alcohol didn't impact their choices, but it didn't make them less transitive, which was kind of fascinating. Which leads to the last little bit I want to talk about, where we take the same sort of paradigm and the same sort of idea, but now we're going to apply it to older adults. And so we can ask, do older adults make rational decisions? Or is cognitive aging associated with violations of transitivity? So this question is well motivated by established differences in cognition between older and younger adults. It turns out as we get older, there's cognitive changes that happen, and we may be making decisions differently. And maybe this seems obvious, but there's a lot of work in this area. Because again, you're still making decisions. That is definitely a thing. So older adults, on average, again, there's also tremendous heterogeneity among older adults with regard to this, just as there's tremendous variability in health and all these other things. But on average, tend to have significant declines in cognitive abilities, particularly in prospective memory and memory retrieval. But such declines are not universal among all individuals, not by any chance, not by a long shot. And there's some evidence showing that or suggesting that older adults tend to employ simpler, more heuristic-based decision-making strategies. And indeed, there's growing evidence that older adults are able to adapt strategy use to their environments. So sort of this idea that you're using simpler, less cognitively demanding heuristics, but you're better at adapting those to the environment, like choosing the heuristics that may fit better with that environment. So this seems to suggest a great opportunity to try to understand transitive, rational decision-making versus more heuristic, potentially transitivity violating decision strategies. And so we carried out a cognitive aging experiment, choice experiment, and we had 25 older adults, all over the age of 60, in many cases much older than the age of 60. Like most of the individuals were 70 or over their 70, in their 70s, and 25 younger adults, 18 to 30, completed a monetary choice gamble experiment over 2 sessions. Participants are repeatedly presented pairs of binary gambles, same as what I've been talking about the whole talk, and asked to select the gamble they prefer. Stimuli are designed to induce violations of transitivity similar to Tversky. These are very, very similar to the gambles that we did in the previous talk. The previous section on alcohol impairment. And again, within subjects design, all participants completed all trials. Now, just as before, we're going to consider the weak order models, but we're going to add a little wrinkle here. So in the previous 2 papers I talked about, we just had one type of weak order model. It was a random preference, random utility formulation where individuals could have more than one preference state, but at all times they had to satisfy that preference state. At all times their preference states had to be transitive. We can do it other ways. And so we have that formulation, and then we also have a formulation where we call fixed preference plus error. And this would be analogous if you're familiar with like weak stochastic transitivity, things like that. This is analogous to that. The idea that you have a single preference state, but that it's shown with a certain amount of error. So like it's as if I have one true latent preference state that I always use when I make my choices, but I imperfectly show that. It's like I have a trembling hand or something, like I occasionally just say the wrong thing. And we're gonna have 3 different levels of that error, low, medium, high. And we're gonna do that again also for the lexicographic semi-order models. So we'll have our random preference formulation as we had before, and we'll have our fixed preference plus error formulation. And all of these very nicely define constraints on choice probabilities. And so similar to what we did in the previous studies, we're going to develop a very simple model for those Bayesian choice probabilities, a multinomial response model where the parameters correspond to the binary choices or the probability of choosing one object over another. We then impose, or we place the Dirichlet prior over that, and through that prior and its support, we define the various order constrained models, carry out order constrained inference, whether by Gibbs sampling or just kind of taking draws. However we do that, that's how we then obtain Bayes factors between these models and compared to an unconstrained model. So There's so many talks I could give on this, but that's what we're going to do here. So it's just similar. It's similar to our previous classifications, but a little more nuanced, because now we can also look at whether people's preferences are not just transitive or intransitive, but also whether they have more than one preference state or whether they're fixed and they are exhibited with some degree of error. Now, what we have here is, see, this bar is actually in my way. Okay, these are the younger adults. So what we have here are the plots of the Bayes factors. So there's 25 individuals, but each individual's choices we calculated Bayes factors for each of the models. So at the bottom, we have the various models. So here we have the weak order mixture model. We have a weak order model with a high degree of error, medium degree of error, very low degree of error. And then we have the lexicographic heuristic models. And what you see here is that there's quite a bit of evidence. And of course, the y-axis here is the log Bayes factor. What I want to show is that, or what I want to establish here is that we have quite a bit of evidence for the weak order models, for the rational models. And so what you can see is that there's actually several individuals who satisfied the weak order single preference with very little error model, very highly rational, not a lot of choice variability in the younger adults, and quite a bit of evidence for the weak order models, for the rational choice models. And there's a few people here and there who may have been choosing according to a lexicographic, but not a lot. This picture is just intended, this graph is just kind of intended to give a snapshot of evidence for the various models for the young adults. For the older adults, it's quite a different story. You can see that the evidence for the weak order models is muted. There's definitely some individuals, about half the individuals were just barely classified as choosing according to some sort of rational model. There's far more evidence for the lexicographic heuristic models and the intransitive models as there were for the younger adults. And so just kind of show you again, for this model, for the young adults, there's hardly any evidence for the lexicographic mixture model. Older adults, there's quite a bit more. And so, and about half the older adults violated transitivity in at least one stimulus condition, at least once, sometimes multiple times. And so basically the long and short of this experiment, or the long and short of the results, and there's plenty I could go on and on about this study, is that we did find differences between older and younger adults with regard to rational decision-making and transitivity. We saw a lot of heterogeneity among the older adults, but compared to the younger adults, they were far more likely to use, if you want to call it this, a less cognitively demanding heuristic, such as the lexicographic semi-order, and violate transitivity at a higher rate than the younger adults. And they were also less likely, the ones that were rational often had higher levels of choice variability. You can think of them as having higher error rates. And so to kind of bring everything together, rational choice operationalized via transitivity of preference is remarkably stable and appears to hold for a majority of individuals. And there are differences due to choice stimuli, though not always in obvious directions. Alcohol's impact on choice is very interesting, suggestive of stable but noisy choice structure. And there may be differences with regard to the lifespan. And so I guess what I find interesting about this especially is that we can kind of take these sort of paradigms, and in the first case, we said, okay, well, what if the choices did not neatly map onto monetary gambles? What if they were, a little more, I won't say realistic, but they involved a little bit more real life sort of situations. And in that case, we actually found more evidence for rational choice. It was sort of as if these individuals were going to a bar to meet other potential sexual partners, and they were breaking open their laptop and running optimizations in R on the various choices. It's a highly rational process, you might call it this. In the second case, we said, okay, well, what if we were able to cognitively impair those individuals in a controlled study? And we found some differences in choice, but not with regard to transitivity or rational choice as we define it that way. But we did find those differences among the older adults. So there's definitely something here. But but that's kind of a nice overview of kind of these different ideas, like, testing that across different stimuli, across different like cognitive, levels of cognitive impairment, and across the lifespan. And I'm happy to send these papers along in email or something if you'd like. So many people to thank. This is actually represents a lot of work. So Dennis McCarthy, student Sanghyuk, Mike Rickenvetter, Dane Cavanero, a whole bunch of people. And I also like to acknowledge funding from NIAAA, NIH, and NSF as well. So thank you very much. And I think I'm right at 45 minutes.